Welcome to our review on diamond and graphite. So what we're going to do in this video is just have a look at the different properties of diamond and graphite and how those then relate to their possible uses. So thinking about diamond first of all then, we've got to remember those 5 key properties that you can see. So the first one is that it's insoluble in water, so that means it doesn't dissolve in water. Second is that it does not conduct electricity. It's hard, it has a high melting point, and it's lustrous, which basically means it's nice and shiny. So what you've got down at the bottom there, in the bottom left corner, is the diagram they're likely to put on your exam paper of the diamond structure. Now the easiest way to remember this, in terms of identifying it, is as a triangle. Okay, so that triangle in the middle there at the bottom is just to remind you the structure of diamond is the triangular one. In terms of what we use diamond for, you need to know about 2 particular uses. First one is we use diamonds in jewellery. 2 reasons for that. One, it's lustrous, which gives it that lovely shiny appearance, and secondly, it's insoluble in water. It'd be rather traumatic if you imagine having a lovely big diamond ring and you get in the shower one day, get out, have a look at your ring, all of a sudden the diamond's gone because it's dissolved. So because it's insoluble in water, you get to keep your nice shiny jewellery. The second use then is in cutting tools, and the 2 key properties we need to remember there is that it's got a high melting point and it's hard. Basically that diamond ends up on the end of drill tips and the edge of cutting blades, so it's got to be hard so it doesn't just break, and it needs that high melting point because the amount of friction we generate as things are being cut or drilled is very high and we don't want it just to melt away. The second material we're going to consider then is graphite. So this one has a few more key properties we've got to remember. First one being it's lustrous. If you look at the picture in the bottom right there, you can see it has that shiny appearance still. It's also opaque, which means it doesn't allow light to pass through it. It's a soft material and it's slippery. It's got a high melting point, it's insoluble in water, and it will conduct electricity. Now in the bottom left we can see again the picture they're going to put on your exam paper when it's asking you to identify which structure is graphite, and the easiest way to remember that is as these stacks of lines. Okay, so if you think about diamond as the triangle, graphite as stacks of lines, it'll help you to identify those different structures. In terms of what we use graphite for then, we've got 3 uses we need to consider. First one is that when we refer to pencil lead, we're actually lying, because that lead inside our pencil is in fact graphite. Now the reason we use graphite inside our pencils is because it's soft and slippery. Kind of important because you don't really want to be trying to write on paper and having it just slice through it, so the soft bit's important, and slippery allows the graphite to transfer from the actual pencil itself onto the bit of paper. We also use it in lubricants, so this is actually mixed in with oil. Now the reason we do that is because it's slippery, so that means it's obviously going to be very good at lubricating joints, and it's got a high melting point as well, so as it's passing through engines it's not going to be affected by those high temperatures. The third use on there is something that we have mentioned going back to our C2 topic in our core science, which is to use it as electrodes in the process of electrolysis. Now the reason that we can do this is it's insoluble in water, so it's not going to dissolve in those liquid solutions, and it will also conduct electricity, which is obviously very important when we're thinking about using it as an electrode in electrolysis. So a key word we need to make ourselves aware of and its meaning is the word allotrope. So when we're talking about diamond and graphite, we're referring to allotropes of carbon. So what that actually means is a different form of the same element in the same physical state. So both diamond and graphite are made of carbon atoms and they're in the solid state of matter. So it's the same element in the same physical state, but they're completely different forms. If you think about the difference between graphite and diamond, you can see how different they can be despite being exactly the same components making them up.